I have been asked by the owner of this beautiful Pioneer SPEC-2 amplifier to make a video similar to the one I made on the, what was that, the Pioneer SA708. So here goes. It's obviously a much simpler amplifier device because it's just a power amplifier. So on, facing the amplifier, you've got a proper toggle main switch, 2 power meters, a protection indicator, and level control. I like the idea of level control on the front of the amplifier, on a power amplifier like this, because it helps for matching channels, it helps for matching levels between this and whatever preamplifier you might connect to it. Obviously, the other thing that's also wonderful on this style of amplifier from the 70s are the rack mount handles, which helps a great deal to maneuver the amplifier in and out the rack and on the bench and wherever you want to put it, because there's nothing as terrible as dealing with a very heavy amplifier and without any real place to grab onto. I just want to turn this light on, and then on the top view, just position that like so. The top view, obviously a toroid transformer, the mains filter capacitors, which are paralleled. Those two work together, and the rear two works together for the plus and minus rails. It is unfortunately not a system where, for instance, these two capacitors serves the left channel and those two capacitors serves the right channel, but that's perfectly fine. There's more than enough dual reserves here. These are 15,000 microfarad 100 volt capacitors each, so you've got 30,000 microfarads and 30,000 microfarads, which is quite stout. Then moving over to identical channel modules. They are identical, and I want to assume that way back in the 70s when these were built, the amplifier modules would have been constructed by a department on their own and tested on their own, and then just simply dropped into the main chassis. And the circuit is described as an output capacitorless triple output stage amplifier. I actually need to, oh gosh, slipped off the face slipped off the edge of the table. Gosh. The stage is relatively simple in terms of high power amplifier stages, where you've got a current mirror pair where the signal comes in a PNP configuration with super matched devices. And the devices that's in here, in my previous video I showed it, they were hand matched and comprising of separate transistors. The originals were super matched devices made by Mitsubishi, but they've got a tendency to drift, to go out of their matching spec. And the output devices are just like proper stout 15 amp 200 volt devices, 3 per rail and 6 in total, which is good for its rated 250 watts, peaking at 500 watts or 500 watts in 4 ohms. Interesting thing is this amplifier's got a switch at the back for the selection of 4 or 8 ohm loudspeaker operation, and that helps navigate the current limiting circuitry on both channels. In the between the output transistors and the driver stage sits a symmetrical pair of almost Darlington connected transistors that senses the driving current and driving voltage, and they are adjusted by those blue potentiometers that you see over there on each side of each channel, and they engage between the 8 ohm setting and the 4 ohm setting on different levels. And again, it's very clearly laid out in the service manual for the SPEC-2. Also, this amplifier is extremely interesting in that it's got input mains voltage current limiting on a relay there with a resistor that obviously gets bridged out within a couple of milliseconds. Then it's got speaker protection relays for each channel, or it's got a speaker protection relay that manages both channels, and it's got and this is where it gets really interesting, it's got relays that engages both a very low level and a full voltage level for the power supply section. That's the low level voltage serves as a Inrush charge up system for the big capacitors before full power gets applied to them. I find it fascinating. I'm curious why Pioneer chose to do it that way, but then again, this amplifier was built in a time when it was quite a big feat to build a big amplifier, a high power amplifier like this. Very few companies attempted to do that, and but yeah, so in the early 70s, when they started building these amplifiers, there was a couple of birthing issues where they had to figure out how to do certain things. These days, we know in a big amplifier with big capacitors, all you really need is an inrush current protection system on the input of the transformer, and you'll be fine, as done by many big amplifier manufacturers. It's equipped with a full DC offset protection system, and obviously it's got this rudimentary overload system that clamps the driving current to the output devices with symmetrical clipping. It's a system that's been employed by many other manufacturers, but there's a lot of manufacturers also that favors against that, saying that it influences the sound in a bad way. The amplifier, the channel matching on the amplifier is pretty good. If we can just focus in on the screen of the audio precision, there we go. And then if we switch over to total harmonic distortion, also as per the manual, the quoted specs and the manual. Let me just lock the level here. There we go. So yeah, let's just check the phase relationship. That's wonderful. That's what you want to see. And it's a lovely amplifier. Noise specification is all right. It's on the older amplifiers, you're not going to get super spectacular noise levels, but it's perfectly fine. It's certainly from a audible perspective on regular loudspeakers, this thing is super quiet. There's no audible buzzes, there's no hiss, there's no artifacts that distract you from listening to the music. And I've just once again also got the voltmeter hooked up on the bias voltage, just keeping the bias voltage in check to make sure that it's stable. I've adjusted the bias voltage over a couple of sessions to just get it in a super sweet spot where I'm very happy with it. And just keeping a check on the heatsink temperature. They seem to get a bit warmer than this amplifier's modern counterparts, because the heat sinks back then were a little bit thin. The designers and the manufacturers neglected to realize that, you know, there's ways that you can make the heat sinks much more beefier to sink heat away much quicker. And I'm not talking about the, you know, an economy situation. I'm talking about just genuine the design of heat sinks. That was a problem for many manufacturers. There's an advert out there that was published by Marantz where they laid claim that they made this cooling tunnel system with the transistors having little sub-heat sinks protruding into an aluminium tunnel with a forced cooling fan that you know, blew a constant current of air over the devices, and you know, it was all just you know, a lot of weird efforts to get to cool transistors properly. And these days we know that you know, you make the bed onto which the transistors bolt onto, make that nice and thick, and make your fins that radiate from that nice and thin. And the more fins you can get onto that thick mounting bed, the better. What else can I tell you about this amplifier? It's a rarity. It's special. It's heavy. It's beautiful. What I've done here is I've replaced the dead incandescent festoon bulbs with LEDs. I've included a tiny little circuit here that rectifies the AC voltage with its own smoothing cap, so that you don't get that flickering on the LEDs. The color on the phone and the color in real life differs vastly. In real life, it is a beautiful, lush green, like almost like an emerald, you know, a beautiful radiating emerald green. And I bought these LEDs specially from a big component retailer to get as close as possible to the original green color. And I had to explain to the owner that the green is so vibrantly bright because with the festoon bulbs, where the glass gets coated in a colored dye, their color fades over time very quickly because that colored dye burns away, and you end up with this dull, dim-lit, warm white-lit meters that you know, looks a bit tired. So this is, you know, this is what Pioneer intended this amplifier to look like, a nice green look. And not long after this green look, they switched to that blue fluoroscan system. And anyway, but they never. That's an interesting thing that I've never seen Pioneer do, is doing a power amplifier with that trademark Pioneer fluoroscan meters on the front. That would have been something quite cool looking, I would want to think. But that wraps it. The next thing I have to do with this beautiful big amplifier is to pack it securely for its trip from me up here close to Pretoria down to Cape Town, which is about 1,400 kilometers, and I have to pack it securely to survive the trip down there, and for the owner to enjoy it once again for many wonderful hours of listening bliss. Thank you for watching. Thank you for supporting my channel. Thank you for subscribing, and thank you for listening. And enjoy the videos, and ultimately enjoy the music.